Hi everyone, and welcome to today's live stream. I'm Aaron, and today's live stream is going to be on redox reactions. First, I'd like to give a shout out to our sponsors, Actua and Promo Science, for making all of this possible. So let's begin. So we're talking about redox reactions. So what is a redox reaction? Well, a redox reaction is a type of reaction where the oxidation states of atoms are changed. And by that, we just mean that there's a transfer of electrons. So the oxidation state refers to the change in the electrons. And the way we remember how this reaction works is with Leo the lion says Gur. So Leo, loss of electrons is oxidation, so LEO. And Gur, GER, gain of electrons is reduced. And the gain of electrons is reducing because electrons have a negative charge. So why are redox reactions important? Well, vitamins are known as antioxidants, which means they prevent atoms from being oxidized by losing the electron themselves, by being oxidized themselves. And that's good because things like free radicals in our body can be harmful to us because they perform reactions that we don't want to happen. So we can actually use these redox reactions and use these vitamins to see how much are contained in certain foods that we eat. So for our first little experiment, I have with me here some iodine starch indicator. So, and I also have a few different common solutions here. So this is just some plain water. We have apple juice, orange juice, lemon juice, we have 7-Up, and we have milk. So I'm going to take a little bit of the indicator and we're going to add them to each of these solutions, and we're going to see which one has the most vitamin C. So if anyone has any guesses as to which one might have the most vitamin C, throw them in the chat now. So the water obviously is not going to have anything in it. So we pour it in. The water was clear, but now we can see it has kind of a purple, cloudy color to it. So that's our base, that's our control. So what happens when we add some to the apple juice? So it kind of gets a very cloudy brown color. So the darker this gets, the more vitamin C that we have in each solution. So this time to the milk. Bit harder to see this time, but it is kind of a dark purple. So the lemon juice. And very similar to the apple juice. And now for 7-Up. Of course, 7-Up is supposed to be made, at least, with lemon and lime juice. But we can see here that it's just kind of purple. And finally, the orange juice. So mix that up. And again, it gets quite dark. But not as dark as the lemon juice. Of course, there were different shades to begin with. But as you can see, the orange juice is still a little bit more purple, a little bit less dark than the lemon juice. And in fact, if we were to read on the backs of the nutrition facts here, we can see that for every 5 mils of lemon juice, there's 2% of our daily vitamin C. And if we were to look at the orange juice, we would actually see that there's less than that. And the apple juice also has a very similar amount to the lemon juice. So that's just a simple little test that we can use to compare different solutions and see the amount of vitamins that we have in each. But what's really happening? Well, what's happening is the vitamin C is oxidized and the iodine is reduced. So when the iodine is reduced, it's able to react with the starch in our indicator, and that's why we get that color. So the lightest has the most vitamin C, and the darkest has the least. So we can also show redox reactions, not just in our body, but they can happen anywhere in solution. So what we're going to do now is I'm going to take this. It's called the U-tube. Really cool looking thing here. And I'm just going to, I have 2 pencils here. And each pencil has a clothespin on it and an alligator clip. And the alligator clip is attached to the pencil lead, which is made of graphite, which conducts electricity. So to the U-tube, I have, I'm going to add a salt solution. So this is just salt and water, plain salt and water. And I'm going to add some universal indicator, which you might recognize from some of our other videos. And I'm going to be pretty generous with this. Give it a quick little mix. And as you can see, it's green. So I'll set up the U-tube here. And I'm just going to add our salt solution to the U-tube. Coincidentally, I'm playing with the U-tube on YouTube, so. So then we're going to put the pencils in to our U-tube, and so that they are submerged in water. And I also have a battery here. So I'm just going to hook each side up to the battery. So it's a little hard to see at first. To rearrange this. That's the fun thing about science is, well, it doesn't always work the way you want it to. So now, it's probably, you're not able to see it, but there are bubbles forming on the leads of the pencils. So this reaction is pretty slow at first. And in fact, we can probably add a little bit more indicator. So, well, you know, life doesn't always go the way you want it to. But let's talk about what is supposed to happen here. So, and we might see it after a while. What's happening here is through the salt solution, the electricity is allowed to travel through. And when we add the electricity to this solution, what we're doing is we're actually performing a redox reaction with the water, not the salt or the graphite. It's actually the water. So we're actually splitting the water. So we're taking the water apart, and this is happening at the anode. And the solution will change color. This is based on the pH, because when we destroy the, or not destroy, but when we split the water molecule, we're creating hydrogen atoms in solution, which make the solution more acidic. And because the indicator is in the water, we should observe a color change. So that was a short one today, and unfortunately I couldn't get this to work. You know what, let me get a pencil here. If there's any questions while I grab this pencil, feel free to ask, and I will answer them. So I'm just going to replace the pencil here, and I think the lead broke in that one, so probably weren't getting exactly what we wanted there. Okay, see some bubbles now. We might work yet. Oh, there we go. Now we're starting to see. Yeah, so you can see that this side here is actually a lot more blue and purple, and this one is getting a little more yellow. And eventually this side's going to turn red. And it looks like it's just about there. So let's toss in a little more indicator, just so we can see this side a little bit better. Oh wow, great, perfect. Never give up, kids. So there, and now it's a completely visible redox reaction. So is there any more questions? Any questions about redox reactions or vitamins? That looks great now. Well, if there's no questions, that's going to do it for today. And I hope everyone has a great day. And make sure to tune in tomorrow for our next live stream. Bye, everyone.